Hi. So now let us see very important definitions. These are required for our normalization concept, that is partial functional dependency and full functional dependency. Okay. So let us try to understand these two. What are these partial and full functional dependency? So let us see the first of all partial functional dependency. So as name implies, actually we know already functionally dependent, its meaning. So some set of attributes deriving some other set of attributes. So that is functional dependency we see. But what is its meaning actually? Partial. So you can see a functional dependency x to y. If you take x is deriving y, so here x is set of attributes and y is also set of attributes. Is a partial dependency. When it will become partial dependency? If proper subset of x. So proper subset of x is determining and other non-key attributes actually. And we know already that key attributes, non-key attributes, that is nothing but prime attributes and non-prime attributes. Okay. So for better understanding, what we will do is, let us take a simple example. So here the relation is R, A, B, C, D. So total 4 attributes are there. And its corresponding FDs are these things actually. AB deriving C, B deriving D. The very first thing is whether it is partial dependency or not. To confirm that, identify the candidate key from this. So we already practiced a few things, a few examples that how to find the candidate key. So in the RHS, whichever attributes are not there, let us take them first of all. So here A is not there, B is not there. Let us take AB. So try to find out AB closer. So AB closer, A, of course, A and B itself you can add. AB deriving C, okay, and B deriving D. B is there, so B deriving D. So because AB is deriving all attributes in the relation, then this is the candidate key. Is it or not? Candidate key is AB. So that means key is AB actually. Now, how you will decide whether it is a partial dependency or not? So, okay, here AB is deriving C. If you observe, B is a key attribute, prime attribute. So, A comma B are going to become prime attributes actually. Is it or not? So, that is what we already discussed this part. Now, individually, if A is deriving some other thing or B is deriving some other attributes, so then that is partial functional dependency. So here you can see AB deriving C. This is not a partial functional dependency, but LHS of B, if you take this one, B is a prime attribute. That is the part of the candidate key. Is it or not? So that deriving non-key attribute, non-prime attribute. So this is partial functional dependency. So, but this is not a partial functional dependency. AB deriving C is not a partial functional dependency actually. So always check like this. This is what the subset, proper subset. B is the subset of key, right? So that is what actually. Now let us take one more simple example. So if you take here also, we have 4 attributes in a relation, and AC deriving B, A deriving D, D deriving B. So what may be the key actually? So A is not there in the RHS part, A. So individually A deriving anything, so A closer if you find, so A and A deriving D, D deriving B. Okay, so this is not possible. So actually C is also there. So let us find AC closer. So if you find AC closer, A, C, and AC deriving B, and of course A deriving D. So this is the key actually. AC is the key. So key is going to become AC. Now if you observe, this is fine, LHS completely, complete dependent. Non-key attributes B and D, non-key attribute dependent on complete key actually, that is what. But when you come to here, this functional dependency, A derives D. A is part of key actually. That is what proper subset. Proper subset deriving non-key attributes. So this is also going to become partial functional dependency. Okay, so in this way, any FD, whether it is a partial functional dependency or not, we can derive actually. First of all, you have to find the key. That is what candidate key you must identify. And then any proper subset of that candidate key deriving non-key attribute means that FD is going to become partial actually. Now let us see counterpart for this one, full functional dependency. So what is meaning of full functional dependency? That is what simple you see. If X and Y are the attribute set of relation, Y is fully functional dependent on X. Okay. If Y is functional dependent on X, but not on any proper subset of X actually. So that is what you can see here. For example, so what he is saying is X derives Y. So non-key attributes you are unable to derive with the proper subset of X actually, opposite to this one. So let us take one simple example here also. So here if you try to find out the key, A, B closure we are going to take because A and B are not there in the RHS part. So A, B closure if you find the A comma B, AB deriving C, C deriving D. So that's it. So this is the key actually. So key is going to become AB. Now what is happening? You see, this is completely deriving non-key attribute. And here if you see this FD, C to D, C deriving D, C is not a part of key actually. That is what, right? Not a proper subset of X. So C is not a proper subset of X. So this is fine actually. So this is full functional dependency. Of course, this one is also full functional dependency. Okay, because all FDs in this set are full functional dependency. So this is not a problem actually. Okay, now let us take one more simple example here. So even here also try to identify A and C are not there in the right side. So AC closure if you try to find out A, C, AC deriving B here and B deriving D. So key is going to become AC. Now what we have to check is, this is fine, this is full functional dependency. Then B derives D, right? D is part of key? No. So this is full functional dependency. Here D is part of AC? No. So D derives B. So this is also full functional dependency. This is also full functional dependency. So there is no problem in this set of FDs actually. So this is what, first of all, partial functional dependency and full functional dependency. So in the key, if any prime attribute deriving non-key attribute, then that is partial functional dependency. If such a dependency is not there, then that is full functional dependency. Now, based on this understanding, what we can do is some important points you can write down. When partial dependency guaranteedly not exist in the table. So that is what you can see here. When partial dependency not exist in the table. So the case one is if primary key consists single attribute actually. So here if key have only one attribute, then there is no chance of having part, right? He is saying proper subset. Okay, so proper subset means not itself and not phi. So when you have a single attribute, there is no chance of having a part of that single attribute. So then you don't have partial functional dependency. And in the another case is if all attributes in a table are part of primary key. How many keys are there? How many attributes are there in the relation? If all of them are the keys actually, for example, key equal to ABC, then also there is no chance of having partial functional dependency. And one more case is there, if table consists only two attributes. At that time, either both of them are the candidate keys or primary key, or one of them is the candidate key. So if one means that scenario is this one, single attribute. So this is what actually, first of all, partial functional dependency, full functional dependency. These two things we are going to use in the normalization, especially second normal form actually. So second normal form is completely basing on these two definitions only. Okay.